vocabulary, lists the difference between supervised and unsupervised learning, probably one of the fundamental breakdowns in data science. And supervised learning uses known and labeled data as input. Supervised learning has a feedback mechanism. Most commonly used supervised learning algorithms are decision tree, logistic regression, support vector machine. And you should know that those are probably the most common used right now, and there certainly are so many coming out. So that's a very evolving thing, and be aware of a lot of the different algorithms that are out there outside of the deep learning. Because a lot of these work faster on raw data and numbers than a deep neural network would. Unsupervised learning uses unlabeled data as input. Unsupervised learning has no feedback mechanism. Most commonly used unsupervised learning algorithms are k-means, clustering, hierarchical clustering, the Aporia algorithm. And there certainly are more. I'm going to say k-means definitely is at the top of the list, and the hierarchical clustering, those two are used so many times. So really important to understand what those are and how they're used. And most important is understand that supervised learning is you have your data set where you have training data and you have all those different pieces moving around, but you're able to train it. You know the answers. And unsupervised, we're just grouping things together that look like they go together. How is logistic regression done? Logistic regression measures the relationship between the dependent variable, our label, what we want to predict, and the one or more independent variables, our features, by estimating probability using its underlying logistic function, sigmoid. And whenever I draw these charts, I always end up drawing them the right-hand side first, because you want to know what your output is. What is you want out of here? And the left-hand side, what do you have going in? So you have your in and out. You can see we have a nice labeled image here to help you remember this. We have our inputs, we have our linear model, we have our probabilities. What are the probabilities of it being a certain way based on these features coming in? The sigmoid function, and it's important to note that the sigmoid function is maybe the most commonly used, but it's only one of a number of functions that are out there. And the sigmoid function turns our probabilities into a value between 0 and 1, or very close to 0, very close to 1, between 0.1 and 0.009. And based on that, we generate an answer, in this case is 0 or 1. How is logistic regression done? So last time we talked about the sigmoid function. Generally, depending on what your interview and level of math and what expertise you're going in for the market, you'll have to understand that formula of the probability equals 1 over 1 plus e to the negative y. And that's e to the base 2. So you have your probability function, or your sigmoid function, which pushes it. As you can see, we have a nice visual of that. And that helps a lot to have that visual on the sigmoid function. You definitely should know your y equals m times x plus c, your basic Euclidean geometry of forming a line, and the slope plus the intercept, the y-intercept. And then you have your natural log, and the natural log is to the e as opposed to a base 2 or base 10. So your natural log to the e of the probability over 1 minus a probability equals your m times x plus c, or your Euclidean line. That helps a lot as far as the graphing and understanding the sigmoid function. So we'll just keep pushing on to question number 3. Explain the steps in making a decision tree. And I noticed last time we brought up the decision tree and the forest, a lot of questions came up. What is the difference? So let's go through that. When you make a decision tree, you're going to take the entire data set as input. You're going to calculate entropy of the target variable as well as the predictor attributes. I remember entropy is just how chaotic is it. So if you have, like, banana and grapes and oranges, if you're mixing in fruit and that's your data coming in, you have all these different objects that are so separate from each other, and the more they become uniform, the lower the entropy. And we call that information gain. So we gain information on sorting different objects from each other. So you have your entropy, you have to calculate your information gain of all attributes, and then you choose the attribute with the highest information gain as the root node. So if you can separate your group, and each group, chaos in each group is lowered, whichever split lowers the chaos the most, that's where you split it, and that's your root node. At that point, you repeat the same procedure on every branch till the decision node of each branch finalized. So understanding that setup is pretty important as far as decision trees, and you can see here we have a nice visual of a decision tree. For example, if you want to build a decision tree to decide whether we should accept or decline a job offer, since these are interview questions, that's a good one to ask. And just as a tip, you should be pretty aware of the formula for entropy and information gain. So you need to look those up if you don't remember those. And the salary, if it's greater than 50,000, no, decline the offer. Yes, it's got a good salary. The commute is greater than an hour. Yes, decline the offer. No. Offers incentives. Yes, accept the offer. No incentives, decline the offer. So we use decision tree pretty much for everything if you want. And if you have a decision tree, then you also should understand how do you build a random forest model. And remember that a random forest is built up of a number number of decision trees. So if you split your data up into a lot of different packages and you do a decision tree on each of those different groups of data, the random forest is bringing all those trees together. So how do you build a random forest model? Randomly select k features from a total of m features, where k is less than m. Among the k features, calculate the node D using the best split point. Split the node into daughter nodes using the best split. Repeat steps 2 and 3 steps until leaf nodes are finalized. Build forest by repeating steps 1 to 4 for n number times to create n number of trees. So you can see it's got the same build pattern as the tree, but instead you're building a number of different trees, little small trees, so it all have an n leaf node. Random forest has a vote at the end, and whoever gets the most votes wins. That's the answer. How can you avoid overfitting of your model? Very important question in any kind of mathematical, scientific, data science setup. In any of them, there are 3 main methods to avoid overfitting, and you should really understand overfitting. Overfitting means that your model is only set for a very small amount of data and ignores the bigger picture. Keep the model simple. Take into account fewer variables, thereby removing some of the noise in the training data. Good advice for any programming at all. Use cross-validation techniques such as k-folds cross-validation. Use regularization techniques such as lasso that penalize certain model parameters if they're likely to cause overfitting. And you should also be well aware that your cross-validation techniques, that's like a pre-data, or your lasso and your regularization techniques are usually during the process. So when you're prepping your data, that's when you're going to do a cross-validation, such as like splitting your data into 3 groups, and you train it on 2 groups and test it on 1, and then switch which 2 groups you test it on, that kind of thing. So can you solve, another one of these, I love these things. There are 9 balls, out of which 1 ball is heavy in weight and the rest are of the same weight. In how many minimum weighings will you find the heavier ball? And when we say weighing, think of a scale where you can put objects on one side and the other, and you can see which side is heavier. And you want to minimize that. You want to split the balls up in such a way that you're going to do as few measurements as you can. You will need to perform 2 weighings. So you can get it down to just 2 weighings. And I always think if there's 9 balls, I'm going to divide them into 3 groups of 3. Place 3 balls on each side. So you can just randomly pick 6 of the balls, and 3 on one side, 3 on the other. And if they balance out, both sides are equal, then you know the heavy weight isn't in any of those. So out of the remaining 3 balls from step 1, take 2 balls and place 1 ball on each side. A little tricky there because I always want to put all 3. I want to put 2 on one side and 1 on the other, but no, just randomly pick 2 of those, put 1 on each side. If they balance out, then the left out ball, the one you didn't measure, will be the heavier one. Otherwise, you'll see it in the balance. You'll see which one's heavier because they'll take one of the balls down. Now we go to scenario B, where they did not balance out. So now we know which side has a heavier ball in it, and it's just very similar to what we did before. If the balls in step 1 do not balance out, then take those 3 balls that had the heavier side on them and reproduce step 2 to find out the heavier ball. Difference between univariate, bivariate, and multivariate analysis. And hopefully, if you know a little Latin, you'll kick in there that you have uni and you have bi and you have multi, because the answer is in the words themselves. So the first one, this type of data contains only 1 variable, so that's the univariate. Purpose of the univariate analysis is to describe the data and find patterns that exist within it. So when you only see one variable coming in this case we're using height of students, you're limited as far as what you can do with that data. So you can come up and draw different patterns and conclusions from those patterns using the means, the median, the mode, dispersion, range, minimum, maximum. So we're describing the data. So all those words would describe the data, and that's about all you can do with data like that. There's no correlation, there's nothing to go beyond that as far as guessing or predicting anything. So we move into bivariate. Uni means 1, bi means 2. Bivariate, this type of data involves 2 different variables. The analysis of this type of data deals with causes and relationships, and the analysis is done to find out the relationship among the 2 variables. And this is always a favorite one because everybody loves ice cream in the summer when it's hot, and very few people go for ice cream in the winter when it's really cold, so it's easy to see the correlation in the data. The temperature and ice cream cells in summer season. And you can see here where the temperature goes from 20 to 35, and as the temperature goes up, so does the cells of ice cream. It goes from 2,000, I'm not sure 2,000 watts. I'm guessing it's a very large chain, because if they're selling 2,000 ice cream cones, and they have a lot of business, good for them. vendor on the corner selling 2,000 ice cream cones a day and 3,100 the next day. Here, the relationship is visible from the table that temperature and cells are directly proportional to each other. So the hotter the temperature, we can predict an increase in cells. So the word prediction should come up. So we have description and prediction. When the data involves 3 or more variables, it is categorized under multivariate. It is similar to bivariate but contains more than one dependent variable. In this example, another really common one, the data for house price prediction, the patterns can be studied by drawing conclusions using mean, median, and mode, dispersion, or range minimum, maximum, etc. And so you can start describing the data, that's what all that was, and then using that description to guess what the price is going to be. So this is very good if you're in the market and you have already looked at the area and you already know that a 2-bedroom, 0-floor, 900 square foot house usually runs about $40,000. You can guess what the next one that looks similar to it is. And I'll just throw in another word in there I don't see very often unless you're really a hardcore data science. We talked about describing the data, descriptive. We talked about predictive, and there's also postscriptive. Postscriptive means we're going to change the variables to try to guess what the outcome is if we change what's going on. So that would be the next step. But that usually doesn't show up unless you're dealing with some really hardcore data science groups. What are the feature selection methods to select the right variables? There are 2 main methods for feature selection. There's filter methods and wrapper methods. And when you're filtering before we discuss the 2 methods real quick, the best analogy for selecting features is bad data in, bad answer out. So when we're limiting or selecting our features, it's all about cleaning up the data coming in so it's cleaner and is more representative of what we're trying to predict. Filter method. Filter methods as they come in, we have linear discrimination analysis, ANOVA, chi-squared. Chi-squared is probably the most common one. And these are all part of pre-processing. We're taking out all the outliers, all the things that have a difference that is very different from the data we're looking at, the odd ones. And sometimes you take the odd ones out and then you analyze them separately to see why they're odd. But remember your filter methods, you want to pull all that weird stuff out. Wrapper methods, on the other hand, are forward selection, backward selection, recursive feature elimination. And one of the most important things to remember about wrapper methods is they're very labor intensive. You have to have some pretty high-end computers if you're doing a lot of data analysis with the wrapper method. And just quickly, forward selection means you have all your different features. They're off to the side and we test just one feature at a time and we keep adding them in until we get a good fit. Backward is we have all the features and we run a test on that to see how well it does, and then we start removing features to see what works. And recursive, which is the most processing hungry algorithm out there, goes through and just recursively looks through all the different features and how they pair together. But again, we have filter method and wrapper method, and it's important to understand that we're sorting the data out and finding out which features are going to represent the data the best and which ones are not going to really add any value to our models. Let's jump to number 8. In your choice of language, write a program that prints the numbers from 1 to 50, but for multiples of 3, print fizz instead of the number, and for the multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fizz buzz. And this really is testing your knowledge in iterating over data. Very important. My sister, who runs at the university the data science team, is in charge of their department. The first question she asks in her interview of anybody who comes in is, how do they iterate through data? So if this question comes up a lot and it's very important you have an understanding, and there's actually a slight error on this code, which I'll point out in just a second. The concept is we have fizz buzz in range, and you have range 51, which in this case goes from 0 to 51, and I'm going to challenge you to see if you can catch the error, and I'll tell you at the end of the code where the error is. What that means is that we're going to go through all the numbers 0, 1, 2, 3, 4, and we're going to process through this loop. If the remainder of fizzbuzz divided by 3 equals 0, and fizzbuzz divided by 5 also equals 0, then print fizzbuzz. Continue. And else if fizzbuzz divided by 3 equals 0, then print fizz, continue. Else if fizzbuzz divided by 5 equals 0, print buzz, continue, and print fizzbuzz. You print the answer. In this case, fizzbuzz is either going to be the number we generated, which is 0, or it'll be the fizzbuzz, fizz, or buzz. Whew, that's a mouthful. Now, if you didn't catch the error in the code, which is always a fun game, find the error. It has to do with the range. And it's important to remember the range here says range to 51. That's 0 to 51, which is correct. We want to go to 51 because it stops. It gets to 50 and it stops. So that's 0 to 50. But if you remember, the question asked from 1 to 50. So the range should be 1 comma 51, not just 51, which does 0 to 51. In this particular script, in Python, you can leave out the continue. But the continue in this script skips the next else if, so it doesn't keep processing it going down. And in programming, a lot of scripts you don't need the continue answers, so it would depend on what script you chose. And there's probably some other ways to do this. It's a lot of fun. And you can see here from the output, we end up with fizz buzz for 0, which shouldn't be there. 1, 2 fizz, 4 buzz fizz, 7, 8 fizz buzz, 11 fizz, and so on. Sounds like a drinking game from my college days, so long ago, many decades ago. You are given a data set consisting of variables having more than 30% missing values. How will you deal with them? Oh, the joy of messy data coming in. Ways to handle missing data values. Data set is huge. We can just simply remove the rows with missing data values. It is the quickest way, i.e. we use the rest of the data to predict the values. You just go in there and say any row of our data that has a NA in it, get rid of it. That doesn't work with smaller data. So with smaller data, you start running into problems because you lose a lot of data. And so we can substitute missing values with the mean or average of the rest of the data using Pandas data frame in Python. There's different ways to do this, obviously, in different languages. And even in Python, there's different ways to do this. But in Python, it's real easy. You can do the df.mean, so you get the mean value. So if you set mean equal to that, then you can do a df.fillNA with the mean value. Very easy to do in a Python Pandas script. And if you're using Python, you should really know Pandas and NumPy, NumPython and Pandas data frames. For the given points, how will you calculate the Euclidean distance in Python? So back to our basic algebra from high school. Euclidean distance is the line on the triangle. And so if we're given the points plot 1 equals 1 comma 3, plot 2 equals 2 comma 5, we know that from this we can take the difference of each one of those points, square them, and then take the square root of everything. So the Euclidean distance equals the square root of plot 1, 0 minus plot 2 of 0 squared, plus plot 1 of 1 minus plot 2 of 1 squared. Mouthful there. And you can remember if you have multiple dimensions that go past 2 dimensions, you could have plot 3 can simply be the distance from plot 1